back to what we've been talking about all week, solving. We have to get x by itself. We cannot get rid of this 8 before we get rid of this negative 4. So what would we do with this negative 4? Multiply on both sides. So the negative 4's cancel on this side, but then get multiplied over here. And then subtract 8 on both sides.
And so what did you do to the negative 4?
Multiplied it on both sides. Remember that you can be checking your answers in Desmos or in your calculator. So if we put negative 28 back in here, that would be negative 20. Negative 20 over negative 4 is positive 5, so that works. Three, this was just simplifying. There were just a lot of fractions in there. So we're multiplying the 7/8 and we're multiplying the 3/5. So I'm going to multiply it all out and then start to simplify. When you multiply your fractions, just multiply together. 28 over 40, x plus, this would be 16 over 1, so whatever that is. Plus 3 over 10x minus 30 over 5. Then we can start to simplify. Some of you may have put it in your calculator and it simplified it for you, and that was fine.
Wait, so you just simplified the first one, like the 7 with all of these?
We multiplied 7 and 4, and then 8 and 5, 7 and 16, and then 8 and 1. So it's always you're multiplying across. 28 over 40 would be 7 tenths. 112 over 18. Sorry, 112 over 8 is 14. 3 tenths is already simplified. And then 30 divided by 5 is 6. So it looks a little bit nicer. Not as big as fractions. Now we can combine our terms. We already have common denominators, so we just need to add the numerators together. And then combine our constants. And then simplify this fraction 1. So all the fractions we had went away. And you just were left with x plus 8. Questions on that one? And then number 5, solving. So what we were just talking about yesterday and the day before, distribute on both sides. We have negative 5x plus 15, double check your negatives, minus 2x equals 46, minus 4x minus 4. So we distributed. And then combine like terms on the same side. So negative 7x plus 15 equals 42 minus 4x. Then you have choices. What did someone move? How did you move? What did you move first? There we go. That's the question I was trying to ask. 4x, okay. If that's not what you did, that's okay. So if we move 4x to the left, we have to subtract 15 to the right. So this would give us negative 3x equals 170. Is that right? And then so remember that as the year progresses, we're going to learn more. The Shark Bites are going to have more on them than whatever we've talked about. information in your head. It's a lot. Right? We have finished the solving multi-step and the word problem, so that's 2 of your 4 objectives. Today we're going to start our absolute value equation, and then whatever we don't finish, we're going to finish on Tuesday, because we don't have school Monday. Because of Yom Kippur. Okay, so everyone should have these notes in front of them. When you are solving absolute value equations, expressions, whatever, it's kind of like when you solve regular equations, but it's a little different. So think about when we're evaluating absolute value expressions, but also mixed with solving. So we're going to be doing both. I'll let you fill this part in first. Okay, so steps 1 through 4. Number 1, make sure the absolute value is isolated. What does isolated mean? By itself. So we have to get it by itself. Then we're going to set the inside equal to both a positive and negative number from the other side of the equation. We'll talk about what that means here in a bit. Then we're going to solve both equations. Then we're going to write the answer in a solution set. So it's going to look like this. X equals, in these curly brackets, one answer and then the other, least to greatest. I remember this one was no calculator. Absolute value is calculator, so make sure you are practicing with your calculator. Right. Anyone still need these steps? So some of these are going to be simple, and then they will get harder as we progress. So following the steps, make sure the absolute value expression is isolated. So that means these absolute value bars, there can be nothing on the outside of them. If there is, you have to get rid of those and then start solving. But in this case, there isn't anything outside of there, so it's already isolated, so check on that. And then we set whatever is inside, we drop the absolute value bars and set it to whatever this is, positive. But because absolute value measures distance, we can also set it to a negative. So you're always going to have, you almost always will have 2 answers. I say that because sometimes you have just one, and it's like 0, but that's the only time.
So what if it's a negative outside the absolute value?
So we'll talk about that when we get to some more details. Okay? So if this was like an actual equation, like x plus 2 on the inside equals 2, then we would solve it, but here there's nothing left to do. So this would just be our answer. We would put it in the solution set, curly brackets, negative 2 and 2. When it's the same like this, like the same number, but just one is positive, one is negative, you could also write it like this. This is plus, minus, or it's called plus or minus. You can write it either way. It just means that your solutions are both positive and negative too. Questions on 1 before we continue? Let's do number 4. Okay. Same as before, look and see, is there anything outside of the absolute value signs? There is not in this case, so it's already isolated. Check on that. Set the inside equal to a positive version of 28 and a negative version of 28. This will be the most missed thing. If you forget to set it equal to both, you will have missed half of the answer, half of the work. So here we have two equations. We have to solve both. So that one's going to give us a -4, the other one's going to give us a +4. So again, we can write it like A equals +4 -4, or you can write it -4 +4.
So the 7 is always negative? Is that 7?
Say that one more time.
So we shouldn't make the 7 positive, right?
Correct. That is
But
not the goal of the absolute value.
But like in number 1, you made 2 positive. And negative.
It was already positive, so
Oh.
we made it equal to 1, and then we set it equal to a negative. So we don't change the value of what's inside. That's not what we do with our absolute value this time around. Other questions on that before we move on to 5? Okay. Same thing. This is already isolated, so check on that. Set the inside equal to a +8 and to a -8. Make sure you're dropping the absolute value signs because you can't solve it if it's still inside.
So now do subtract.
Yes. Subtract 1 on both sides or on both equations. So then when we write our solution set, least to greatest, D equals -9 and 7.
Wait, so don't like -9 and 7 should be like both -7 and +7?
So the only reason they were both the same here is because we only had one number. We didn't have to solve anything. Here, when we solved it, they happened to be the same number. Just one was positive, one was negative. They won't always be the same.
Oh. So like it's still right then?
This is the correct answer. And after we finish this tomorrow, I'll show you how to check this in dozens. Number 8, let's do the same thing. It's already isolated. So drop the absolute value, set the inside equal to a +17 and a negative. And as we start to solve it, what would we do first?
-5 to both sides.
Correct. On both equations, we can do that at the same time. -2b equals 1, 2, and -2b equals -12. And then divide. You get -11 and +6.
So why do you have to do both? Like negative and positive?
Because absolute value measures distance, so it's not just measuring the positive distance, but it's measuring the negative distance also.
Oh.
Okay. Before we go on to the next page, are there any from this page that we skipped over that we want to see we go over?
Week 3.
Okay. So it's already isolated. What would be the next step?
Make the 40 negative and positive.
And positive. Drop the absolute value sign, set it equal to the positive version and the negative version. And then divide. So what would our two answers be? -8. 8, or you can put it as z equals plus or minus. Either or.
So you always should have the negative number before the positive number?
Yes, always leads to greatness. Any others on this page?
Number 7.
Already isolated, let's go ahead and set it to a positive and negative version of 34. After that, how would we start this?
Minus 2 to both sides.
And both equations. And then divide everything by 4. The n equals
Eight and negative 1.
8 and negative 1. Let's go on to the next page. So all of the ones we've done so far were already isolated. Now let's talk about what happens when they're not isolated. In this box, this is isolate the absolute value bar. So basically we're going to do everything we were just doing before, but now we also have to worry about the outside. So let's start at number 9. Here we have something outside of the absolute value bar. So when you have something outside, think about this like a variable. You're trying to solve for that variable, so you're not going to do anything with it until the end. So how do you get rid of the 2?
Add 2 to both sides.
Add 2, subtract.
Subtract.
There you go. Make sure your whatever's inside the absolute value bar stays inside the absolute value bars until it's isolated. It has to be in absolute value bars until it's isolated. Then, once it's isolated, the rules are the same as before. Isolated, drop them, set them equal to a positive and negative value. Questions on this one before we continue? Let's try number 11. There's something outside of the absolute value bar. So if that was just a variable, how would we get rid of 6?
What number?
11. Divide. You have to treat this like a regular equation until it's isolated, and then it becomes its own problem. Now it's isolated, so we can drop the absolute value bar, set it equal to a positive and negative version, and write the solution set. Let's try number 12. Again. Disregard anything that's on the inside for now. That's like an entire variable. We'll do that at the end.
Don't you like this 2 here?
Pretend there's nothing in there until the very end, until it gets isolated.
Divide where?
Divide by negative 2 on both sides.
Negative 7.
So now that it's isolated, we can drop the absolute value bar, set it equal to a positive and negative version. then to solve, we would do what? Subtract 3, switch both equations. We have negative 10 and 4. Before we do another, what questions do we have right now? Let's try 13. What would be our first step?
Multiply 6.
Multiply both sides by 6. And then,
So number 12 was 4 and 10.
say that one more time.
So number 10, 12 was 4 and 10, right?
Negative 10 and 4, yes. Okay. What was our next step?
Minus 1.
Is that our next step? We are going to do that.
Drop down the
Drop the absolute value bars and do what?
Well, plus.
So we'll keep doing this, but we're missing something.
The other one.
The other one. Make sure you have that other one, or you're missing half the work, half the answer. Last step.
Divide by 2.
Divide everything right over here on my notes. W equals 11 and W equals negative 7. Let's see if we could do one more. Number 14. More complex than the other ones, but we're doing the exact same thing. What would be our first step?
Add, negative 10 minus 3.
Which one are we doing first? If I divide by what? If I divide everything by negative 10, that means I also have to divide this by negative 10. Now we have fractions that we don't want.
Do like
2 minus 10, negative 10 minus 3.
So we can't combine these because this one's being multiplied, but add what? 3. So we can't add or subtract this, but we can add 3. Are we there yet? Is it isolated? Now we can divide. Now we can drop the lines. So we could not have done that before because it was not isolated. And make sure you have the other one. Right? And then to solve. That H, this is for number 14. H equals negative 13 and 3. So on Tuesday, we're going to finish the rest of this, and then you'll have time to practice this and other stuff before you put up your calculators, I just just want to remind you of your 3 Delta Maths that you have due today after school on solving multi-step equations. So that's 2.1, and then the other multi-step equations with variables on both sides. So that's the other 2.1, and then word problems 2.4. So make sure all 3 of those get done today.